It is a great dream possessed by millions of men on Earth. The dream of reaching out into space to look at another planet. But for some men, reaching out to another planet no longer seems a dream at all. Deep in this huge complex of buildings and computers, a handful of men have spent years striving to make that dream a reality. And now they are about to have their chance. One single try, as, for the first time in history, men encounter Mars. A team of men secluded inside NASA's Jet Propulsion Laboratory at Pasadena, California, will encounter Mars through the eyes of a spacecraft launched from Earth 8 months ago. The director of the lab is Dr. William Pickering, organizer of the teams that built the first U.S. Earth satellite, the Rangers that photographed the moon, the Mariner probe to Venus, and the Mariner 4 team now about to face its most momentous challenge.
We're about to encounter the planet Mars with a spacecraft built here at the Jet Propulsion Laboratory. Down in that building, the television and press are gathering, and when it flies by the planet, they will report to the world what the spacecraft is able to see and discover about Mars. But what the press and television and the rest of the world cannot see is the actual encounter of Mars by the men who are experiencing the encounter. Down there in another building, the Spaceflight Operations Building, a team of scientists and engineers is talking to the spacecraft, listening to it, controlling it.
Behind doors closed to public view, you are about to see the human side of this event, the encounter through the faces of men. As the voice of the spacecraft speaks in the form of graph lines and numbers transmitted across 134 million miles of space and picked up by tracking stations from South Africa to California, the members of the flight operations team, 200 in all, approach some of the most important hours of their lives, the realization or possible failure of a dream.
If they control it well and make all the right decisions, and if all goes well, they will achieve a feat unique in the history of science. Success of the mission depends on what kind of men they are and how well they stand up under tremendous pressure.
The tremendous pressure on the Mariner team is focused on its project manager, Dan Schneiderman.
The planet is 22 degrees in diameter. Keep that in mind. The planet
Schneiderman is in effect the pilot of the spacecraft, overseeing its course and operations of its science and picture-taking equipment. With the help of Jack James, project manager during design and launch of Mariner 4, and Bill Collier, Schneiderman rehearses commands he would send to the spacecraft in case of emergency. Mariner contains its own automatic instructions, but these could go wrong, and Schneiderman's team has decided to send backup commands from Earth, a decision that raises another worry, that Earth commands could upset operations the spacecraft is designed to perform for itself.
These are the questions. This is the soul searching you go through. Boy, don't worry. Our first reaction was, man, let that spacecraft perform for itself. Let's not horse around with it. But as soon as you start really asking these questions of yourself, then you begin to think, we can't take a chance. We've got to put ourselves in a position where we've done everything we can humanly do to ensure, or at least to enhance, the chances of success.
Months ago, the Mariner team scheduled the commands to be sent during encounter. A radio command that could circle the Earth in 1.5 seconds takes 12 minutes to cover the immense distance to the spacecraft.
If the tape recorder fails to turn off, we cannot tell that until at least 5.
The Mariner team has had to predict possible failures in order to plan corrective commands that would have to be sent before they even discovered that anything had gone wrong on the spacecraft.
To send a command up to the spacecraft, DC-16 in essence, and it takes 12 more minutes for the spacecraft to receive this information. In that period of time, both tracks have been erased.
A stunning thought. The recorder could tape pictures of Mars, then erase them before they could be transmitted back to Earth. One solution is to send another command.
And that's the rationale behind the transmission of DC-26, is to protect the pictures.
By this time Wednesday, we won't be as calm as we are right now.
Well, I'll tell you something. When we get this far Wednesday, I'll be very relaxed.
Oh, I know that. But we'll...
This discussion of losing Clopus Lock is meant to make a nervous man.
Oh boy, that just really scares you. It really does.
That one scares you.
Because
if that hits us, we are really in trouble.
Boy, we're going to have a frantic day, no matter what time that must occur.
You're not the director again.
If the project manager is in effect the pilot of the spacecraft, he has some passengers. Richard Sloan is Mariner project scientist, Schneiderman's contact with 24 scientists from 10 different universities and laboratories who have 7 experiments working aboard the spacecraft. Next door to operations is the space science area, where the concern is less with the operation of the spacecraft than with Mars itself. Dr. James Van Allen, discoverer of the radiation belts around the Earth, has been conducting one of the 3 experiments measuring interplanetary radiation. Now he hopes to measure the radiation close to Mars and discover whether it has radiation belts like the Earth's. Dr. Arvidas Kleor, who hopes to find out the density of Mars' atmosphere. Dr. Robert Layton, who hopes to get back man's first close-ups of Mars. His associate, Dr. Bruce Murray.
Mars would be this big. We want the pictures about 2 or 3 times that big, so we're talking about Mars distance.
Mars gets to be about a couple of meters in diameter there.
Layton took some of man's best telescope pictures of Mars 9 years ago. Now he hopes Mariner will send back 21 close-up pictures detailing 1% of Mars' surface. The climax of a lifetime of interest in fascinating details men already know about Mars.
It has seasons because it tips its axis to the sun in a regular way, going around the sun with seasons very similar to our seasons in their nature. It has light and dark markings, which show changes. It shows clouds in its atmosphere, and these clouds have been attributed both to water vapor or condensed water, and also to dust. There are yellow clouds and white clouds, I guess.
Blue clouds.
And blue clouds. All right.
Clouds in the Terminator, and clouds that don't move, that stay fixed on the planet, and clouds that move on the planet. The point is it has an enormous variety of things, even at this distance.
I think also briefly that one of the reasons it's such a fascinating subject is that it does have change. But the fact that it has so much of what we're familiar with and so much of what might prove to be interesting and crucial, as a matter of fact, in our real understanding of the nature of life, I think is what really pushes us on. Isn't that right?
And we still have a spacecraft to fly.
With a final talk to his team, Dan Schneiderman concludes their last rehearsal for the encounter with Mars. The operations team will continue to monitor the spacecraft for the next few days, while some of its members will have a weekend of rest before the big event. Driving up Mount Wilson, Layton leaves the Mariner project behind for a day. But the dream of exploring planets will not be swept from mind by a family picnic or some extra work washing the mirror of a telescope.
I think that Mars, of course, is a very easy thing to make extravagant statements about and have a lot of wild ideas about, and there have been wild ideas about Mars. I've often thought about not only Mars, but Jupiter and other planets elsewhere in the galaxy, where undoubtedly there are things going on. I can imagine there's a place on Mars, for example, where the wind is blowing and little pieces of dust are flying around the way they would be on sand dunes, say, on the Earth. One can imagine there are planets with life, dinosaurs, and it's interesting to consider how life on another planet might be similar to life on Earth.
On his weekend, Dan Schneiderman leaves the Mariner project ashore, but the spacecraft is flying toward Mars at 64,000 miles per hour. It will arrive in less than 80 hours, and try as he will to relax, Schneiderman cannot but wonder what man will see in his closer look at the planet.
It's interesting to look at things and look at them as you get closer. For example, if you go far away from, let's say, if you were an angel or something like that there, and you float high above Southern California, you look down, you might see a greenery. See? And then you lower your altitude a little bit, and this greenery becomes patchy greenery. In other words, what looked to be homogeneous all of a sudden becomes random. Okay? You come lower, and all of a sudden what you're seeing is a single forest. So what was random becomes homogeneous again. You see? So the interesting thing is, I think that if you take a picture, and let's presume it shows a canal, that doesn't mean to say that that is just a random crisscrossing of weird things. That isn't really a canal at all, or even a pathway. You gotta get closer. You gotta always get closer and closer.
The day of the encounter. Schneiderman and Layton and the Mariner team have already begun the encounter operation. The spacecraft is flying toward Mars, about to pass within 6,000 miles of its surface, and then out into space. One pass, a single chance for everything to work. The experiments, camera, picture recorder, and the commands even now being sent from Earth. While the Mariner team is working behind closed doors, the nation will see reports on the encounter from this auditorium, with its replica of Mariner 4. Its arms, spanning 22 feet, are covered with solar cells. Its body is packed with instruments for the 7 science experiments, including the camera and tape recorder for taking and storing the pictures for later playback to Earth. Peering out of the body is the camera scan platform. This morning, a command from Earth started this platform sweeping up and down. The next command will halt the platform, aiming it where Mars should appear at encounter.
This is Mariner Control Center at JPL. Mariner 4 is currently being tracked by Station 51, Johannesburg. The spacecraft is 134.217 million miles from Earth and 50,142 miles from Mars.
Now the operations team sends a crucial command, ordering the scan platform to stop, fixing its aim. The team waits a tense 24 minutes to hear whether or not the spacecraft will respond, and if it does, whether the aim will be right for pictures of Mars.
DAS data reports the scan position for frame 605 as decimal 323. Congratulations. Data encoder, counter 4 event with DC-24.
323, right on the button, exactly where they wanted it.
Exactly where they wanted it. The scan platform is aimed where Mars should appear.
Good. 0.74 degrees from where we wanted to be.
Yeah, I noticed that.
Did you get to the 0.4?
Denton Allen and Bruce Murray let their imaginations play with what a picture might show.
What are we going to do when we see H-E-L-P stamped out in the snow? What John Cassani says we're going to see is a bunch of flak. These guys are going to be firing at us as we go by.
The first picture will cover an area of approximately 176 miles square on the sunlit limb of the planet.
I wish I were as sure as he is.
About 12 minutes from now, we should be able to determine that the TV camera shutter is operating and that the recorder is running, although we will not be able to determine definitely whether pictures are actually being recorded on the tape until they are played back.
Now the most crucial moment for the Mariner team.
Right, that's all right. We should start, we should start right about
It is time for the spacecraft to detect light from Mars, start the tape recorder, an actual taking of pictures.
I'll tell you what, I'm mighty glad to hear that they got a neural angle signal. A big static. Yeah.
Picture taking should have begun 12 minutes ago, but if Schneiderman learns that it did not, nothing on Earth he could do could make up for the failure.
Oh.
Angle. It's time for 26 to go. Yeah, Tim.
The DC-26 command is sent to turn off the tape recorder in case it has failed to stop and is beginning to erase its own pictures.
2815. There it is.
Systems manager John Cassani sees it first.
Now sit back and look at the frame count.
Very good.
We had normal calibrated 09.
A tremendous moment for the operations team. Mechanical failures could still occur, but the human beings have made all the right decisions to fly a spacecraft to Mars, to start the camera shutter working and the tape recorder storing pictures of the planet.
It makes you feel like you're in the cockpit of a spacecraft going past Mars.
Okay, I stand corrected. 100,001.
Gee, it's not safe to say that's the only thing, because we're really subject to
Just say everything is okay.
almost anything could occur.
Okay, good. I'm going to go get some lunch here. I hope in about another 15 or 20 minutes.
I just hope nothing unusual. I hope it keeps right on. Being just as easy as it's been.
Yeah, that's what I want to do.
Data continues to flow in, reporting the progress of picture taking. Not all the signs are good. Though most indications are that the recorder is working properly, one signals the opposite. The possible sign of a malfunctioning tape recorder.
Yeah, what about the tape recorder?
Well, the tape recorder, the answers that I got late here is that we got a normal first end of tape and a normal second end of tape, and it appeared as though that the second end of tape switched the data encoder to mode 2, just as it is supposed to. But the answer here, the last I heard there, was that there was some funny business in the first 10 picture recording.
That TV system, which we should have turned the tape recorder on and off, may have failed to turn it off, and the tape runs through faster. And that was exactly the reason we sent this command 26, was to save as many pictures as we could on the tape. So we don't know for sure it's happening.
Give me the actual time of transmission of DC-26.
If Mariner 4 has recorded pictures, they will be held on tape while the results of other experiments are radioed to Earth. It will be 10 hours before picture playback can begin. Each picture will require more than 8 hours to transmit. If all 21 are on the tape, it will take 9 days to find it out.
There, give us the word. But I think it doesn't look like we look like we got some pictures if the TV system recorded.
Did you see?
There'd be a long wait between pictures.
That were indicative?
That's right. There were not two of the same. Okay, so you must have been skipping one when you're looking at the tape. Yeah. Okay, very good. Just going up to...
Dr. Van Allen and other radiation experimenters are finding that Mars has no radiation belts, and others are discovering that it has little magnetic field. Dr. Cleore's team successfully measures the amount of distortion in Mariner's radio signals caused by their passage through Mars' atmosphere. And they can deduce that the planet's atmosphere is thinner than expected, as thin as the Earth's at an altitude of 100,000 feet. But the world has been waiting to hear about the picture-taking experiment. And now Dan Schneiderman must tell the press and television what he knows.
The performance of the spacecraft during the picture-taking sequence was not precisely as predicted. There were some anomalies, and we have attempted in this short period of time to diagnose these anomalies. And I think that at the present time, we are still optimistic that we did indeed take some pictures. We have always said that we cannot determine whether or not these pictures have been taken, even the system performed correctly, until tomorrow morning, when the picture playback sequence will be initiated.
5 a.m. on the way to the Jet Propulsion Laboratory.
Difficulties in this business is that it's such a difficult game that your experience really tells you that almost anything abnormal usually spells disaster. It's very rare that it's just partially degraded. Usually it spells Disaster.
The teletypes are already printing out the first picture signals from the spacecraft. Digits representing the shades of dots arranged in lines. The first numbers indicate black, as the first 7 lines are supposed to be. If the numbers change when the 8th line comes in, they will represent at least the beginnings of a picture image.
They may be all black, but we got some there. Hey, there we go.
There she goes.
Yeah,
That's data.
Based on your preliminary analysis of this data, can you describe what you see on Mars?
Yes, it's there.
That wasn't a fair.
Congratulations to you both, as a matter of fact.
Let's see what the picture looks like now.
Yeah.
Oh, boy.
Give me Bruce Murray's phone number. Or the devil or the Mars picture interpreters. Yeah. Data's coming in, boy. What are you doing in bed? You didn't, huh? Well, the numbers are coming in hot off the line. First, well, yeah, okay. Shave, at least.
It's the TV filter shutter.
Well, that's your problem. I just wanted to let you know that there are Mars pictures coming in and it's starting to stack up on your desk.
For 8 hours and 35 minutes, the figures cascade to the Earth from the spacecraft. 240,000 bits of binary code, representing the shading of 40,000 dots that will finally make up the first picture. A complex system of computers is required to convert these numbers into pictures. But some workers decide to hand-make their own picture of Mars by shading the numbers. A fanciful exercise, but one that gives Robert Layton a chance to commune with numbers from Mars, whose picture equivalent he can hardly imagine.
Joe Christer's printout. I thought I saw some very low numbers. Only 37 to 38. 15, 21 to 15.
They're dancing.
Yeah.
This is the first time you've seen that? No kidding. Hey, that's gorgeous.
What is it?
As you know, the more formal processing of these pictures is taking place.
There's Mars. There's the rest of the shades of gray.
There it is. I think we got some pictures.
Face down, right?
Yeah, face down.
There is some sort of a pattern to the data, and we have now full confidence that this does indeed correspond to a photograph of Mars.
Everything else? That's more like what I thought a picture of Mars ought to look like.
That's right.
Right. Yep. Beautiful picture. Oh, that's grand.
You get ready to run. Yeah.
And what do we got here?
A picture of Mars.
Well, you asked for it. It's history, boys.
It's history. I told you that platform didn't stabilize.
Pouring the wrong plant.
Well, I'll be damned. My gosh, you have amazing detail in there.
The historic first close-up of another planet. Light and dark markings can be seen on Mars. Its surface is separated from the black of outer space beyond by the curving line of the planet's edge, called the limb.
The limb you had to have because if we'd seen number 2 first,
I think there have been people leaping from Building 180. Windows, you know. My God, all this for that?
Picture 2 was taken with the sun directly overhead, flat lighting, and a featureless surface.
Right? You couldn't even prove you'd been to Mars. You really couldn't have been could have taken a picture of, hell, the floor. So flat. Then you, number 3 popped along. We knew we had something.
Picture 3. Features suggestive of ridges, valleys, and crater-like depressions. Man has dreamed of reaching out into space to look at another planet. The Mariner team built a spacecraft, flew it to Mars, and got back 21 pictures. A feat of such wonder that its full scale is to be unveiled for the President in a ceremony at the White House.
Picture number 11 in the Mariner sequence must surely rank as one of the most remarkable scientific photographs of this age.
One of the most remarkable scientific photographs of this age. Picture number 11 shows craters 3 to 75 miles across and several thousand feet deep. The picture suggests that Mars has never had an ocean or substantial atmosphere. The Mariner 4 pictures neither demonstrate nor preclude the possible existence of life on Mars.
I think I speak for every American when I tell you how very proud and how impressed, how grateful we are for what you and all of the many members of your team have accomplished on the Mariner 4 mission. In the history books of tomorrow, unlike the headlines of today, the project's name may be lost. But the names of the men of vision, men of imagination and faith, who made this enterprise such a historic success, is going to be honored in the world for many generations to come. It may just be that life as we know it, with its humanity, is more unique than many have thought.